C3H8. Well, are you sure he said there are 5 isomers of C3H8? Because that's very unlikely. That's very unlikely.
I think it's C3H6, yeah. Because I remember I got one that is a triangle.
C3H6 also shouldn't have more than
5.
2 isomers.
Really?
I mean, you can go cyclical. Yeah, I guess you can go cyclical. That what you draw there is cyclical, right? Right.
Yeah,
Ines, I can
only
see.
got 2.
Right. Let me try. Let me try. Yeah. So I'm just going to draw this at this point. Yeah, because it's not exactly an easy way, easy thing. Okay. Like that. That's your first one, right? That should be your first one, right? And then just to confirm that the H's are 6, so 1, 2, I think 3, 4, 5, and then 6, so definitely 6, right? Okay, right, and then C is here. Now you need to confirm that it's actually 6 also, so 2, 2, 2, 2, and 2, correct?
Yeah.
2, 2, 2. Now, are you sure that the question say 5 isomers? Because 5 isomers tend to happen when things are longer.
Teacher say, maybe he said, maybe he forget, then he say only. But like we the class, like he say just draw everything, then we say like we don't know if we draw finish, so we ask him how many, then he say 5.
No, there
I'll
isn't
ask him in
5.
class. I'll ask, maybe he probably
No.
made a mistake. Yeah.
No, because C3 is a very short thing. The isomer grows more as you have more. No. Not happening. Not happening.
Yeah, that is probably a mistake.
Yeah, it's because the H6 is very restrictive. You cannot do a lot of things with H6. You cannot. Right. So, Ainesh, I'm starting, yeah? Okay. We have been waiting for quite some time. Can you hear us?
Hello, yeah.
All right. So prepare your paper. We will start. We'll start right now. Look at the Jamboard. Okay.
We're not doing math today. I have a math exam.
We are having chemistry today, Ainesh. Like, it's chemistry day. If you want to do math, you do it yesterday.
Oh, what?
What do you mean by what? Monday is a chemistry day.
Oh, that's right. I thought we could like reschedule it because of an exam.
I don't even know your exam schedule.
Oh. Okay.
Just waiting for you in the Jamboard. Ainesh, I'm waiting for you in the Jamboard. Please go in like. The Jamboard is the OChem intro, yeah? All right, good. Page 5. Okay. Now look at page 4. I'm going to revise very quickly. Everybody in page 4, yeah? Okay. We have 4 families. The family of, well, nothing special. The alkane family. Second family is the family of alkene. Well, there is something special, the double bond. Double bond. Look at the C here of alkene. How many hands does it have, John P?
Oh.
Okay. Ainesh, look at the C here in the family of alkene with the double bond here. How many hands does C have?
4.
4. So C always have 4 hands no matter what family. That's just like the how he's happy lah, right? So single bond, a double bond, the family of alkane, the family of alkene. Nothing very complicated, right? The naming and everything we don't care too much today. Now look at the third family. The third family, there's a special thing called OH. Now, Jonty, the O here, how many hands?
Two.
Two. One to the C, one to the H, right? Because that's how O is satisfied. Everybody has to be satisfied here. Just to confirm, Ainesh, the C, this guy, and this C, both how many hands?
4.
Which is what C is supposed to have, right? Okay. Now, usually we don't draw the H for shortcut purposes because H is everywhere. And so we develop a shortcut, kind of formal, that we don't draw the H. Why do we draw the H here, though? Anybody have an idea? We don't draw the H's here, but we kind of have to draw the H here. Anybody have a suggestion?
Because O can bond with other stuff. But she also
Correct. So what's so special about this H? That we do have to draw this guy. We do have to. Any suggestion? Other suggestion?
it can come out, right?
Now, what do you mean by it can come out? I'm sorry.
Because as a nucleic acid, the OH and the N is the H is the one that come out, right?
Don't talk about the acid first. Talk about the alcohol first. Alcohol first. Anish, any idea why the H here is written?
Because there's 5 H's and then there's 1 OH.
Well, the 5 H's are here, but we don't even bother to write the H's. But here, we do need to bother. Why?
Because it's different. It's the ID.
It's the ID, correct? It is the identity of alcohol. It has to be written. The other H's are not the identity, so to speak. So you don't have to write down, just assume that it's there. That's the only reason, right? Okay, I hope that the reasoning makes sense. It's not, it is a rule, but I hope it makes sense, right? So good guess, Ainesh. So look at the fourth family. The fourth family, the ID is a bit long, okay? It includes the C, which is kind of rare, right? It's rare, but that's how we identify the fourth family, COOH. Don't bother to remember the carboxylic acid. It's a very complicated name. If you want to, that's fine. What I want you to remember is visually how COOH looks. It looks like this. You do have to remember the structure of COOH. Okay, we do have to. There you go. Right? And this H and this O and whatever, everything has to be written. Now, any question on the 4 families?
No.
Right, now if there isn't, in page 5, as per usual, Ainesh on the left, Jonty on the right, right? As per usual. Now, write down, draw the example of the 4 families. What you draw will be 2 carbon. Okay, this is the exact same thing as page 4. So I'm just asking you to draw what you see in page 4, preferably without looking at page 4, right? So Ainesh on the left, Jonty on the right. Please draw the examples, 1 each for 1 family. You can write down the name, but I don't care about the name. You can though. You can totally care about the name. Totally fine. And if your name make a mistake, I'll just correct you, no problem. But try not to make a mistake on the drawing part. Try not to.
So just like one example of it.
I mean, what you draw is correct. So just one example. So alkane, the example is that guy, correct. Alkene, that guy, correct. Then alcohol, like what? Correct. Good. You can use your mouse at this point. Yeah. I mean, after this, you just use your paper.
Where are these?
I mean, I guess you can take a peek in page 4. I mean, but try your best not to. Okay, going strong, Ainesh, going strong. Yeah, your carboxylic acid is a bit off, Jonty, but that is the hardest thing. Ainesh, your alcohol is not wrong. Your alcohol is not wrong, but I guess you only need one OH. But you're doing a double alcohol, which is actually fine. I guess it's actually fine.
I put OH as an identity.
Oh, right. That's okay. Fair enough. Fair enough. So the drawing is fine. So both of you, the 3 families are great, but the carboxylic acid will give you some trouble. So feel free to take a peek, but try not to.
I really don't remember.
Just take a peek then, Jonty. It's okay. Totally fine.
Oh, okay. I see.
Going strong, Ainesh, going strong. How come there's a 2O there?
Yeah.
Carboxylic still wrong. Okay, Ainesh also a little bit wrong, right? A little bit. Looks good. All right. Okay. So Ainesh, just to confirm, just to confirm, is this C happy or not?
Yeah.
Is this C happy or not?
Yeah.
This O?
Yeah.
This O?
Yeah.
And the H is of course happy. Okay, good. I gotta do some switch. I gotta do some switch for a while. My battery's running out. Please wait for a while. I'll probably be out of the Zoom for half a minute. Apologies. Your drawing are all correct. All correct. Any questions so far?
No.
Jonty, any questions?
Not really.
And Ainesh, sorry, Ainesh, any questions? Ainesh, no questions so far? All right. Okay, can you guys hear me? Sorry, let me test. Jonty, can you hear me?
Yeah.
All right, good. Okay, I can hear you also.
You're a bit muffled, but it's okay.
If I'm not clear, do tell. Don't suffer such thing. Ainesh, can you hear me clearly?
Yeah.
Okay, I can hear you guys also, so we can continue. Okay, Ainesh, I'll be needing your video, so set it up concurrently quickly. So now we're doing the serious stuff. Revision is over. We're doing the serious stuff. Everything I'm setting up again because I just changed. Okay, all right, I'm in the Jamboard again, right? So Ainesh, I want you to set up your video concurrently while we're doing all this because I need to see your paper. So now everybody go to page 6, right? I'm going to do a reaction map. Reaction map means you can see all the important reaction in just one map. There is a lot of reaction in OChem. If you study separately, it takes a long time to understand everything. Very, very inefficient. Very inefficient. I think that's how your teacher will teach you, teaching them separately. We're going to combine everything into one map, make it very easy to understand. That way, we will be able to use them, because memorizing the reaction is never enough. We need to use them. So my goal with this map is for you to be able to use them immediately in exam level question, which should make you happy, right? And it will make OChem kind of like feels easier. That's the goal. Now, John T, make a guess. How many percent of O level is OChem?
35%.
30 to 35%. I wish it's that much. It's slightly smaller. So Ainesh, make another guess. I cannot hear you.
20.
20, right? It's around 25. Around 25, which is a super big chunk. Super big chunk. I've only seen a bigger chunk in AMAT, 35% for differentiation and integration. Those two combined is 35%. But no other chunk is bigger than that in math, and in chemistry, the biggest chunk is 25%. If you can understand this map, you will secure your 25% rather easily, which is I think a big deal, right? Rather easily, not without effort, still need effort, right? So Ainesh, I think I want your okay, you're on, good. Okay, I do want your mic to be on the phone, right? Okay, clearer that way. Okay. Now, how to say? Stop me when I'm drawing and explaining. Stop me when you don't understand something. Just stop me, because I'm trying to help you understand, not just memorize. With that, things are going to be easy moving forward. So you stop me when you don't understand, right? Doesn't matter. Just stop. Okay. Okay. Ainesh, can you copy me through the handphone because you're not using the phone? Mike?
I would have preferred the laptop, but I can.
All right. Now this is clearer for me, right? Okay. So stop me anytime. Okay. Right. So now look at the look at the Jamboard page 6. Yeah. Now I draw a big C because OChem is about C. Okay. Don't know why historically they call substances with a lot of C organic chem. Whatever. Here's the big C that we start with. And in the big C, you have 4 substances. There you go. I hope you can see the big C. The 4 substances will be the 4 families that we have. So the first family is here. No? You should know what family this is. If you have a name, John D.
Okay.
Good. And then Ainesh, here is the second family. You should know what it is.
Okay.
Good. And then the third family, John T. Whose family is this?
Alcohol.
Good. And then the last one is the complicated looking last family called carboxylic acid. I'm going to spare you the naming for now. So I put the 4 families here, right? Immediately, I'm going to say that there are 2 ways between them, and there is totally no way here. What am I trying to say here? Alkane can become alkene, vice versa. And you need to know the reaction. But alkane cannot jump to carboxylic acid. And that's why we have a C. That's why we have a C. That's what the map is telling us. So what is the map telling us? Let's see. Ainesh, can you jump from alkane, transform it directly to alcohol? Do you see a way in the map?
No.
And that's because there isn't, at least not in O level. So if they ask you to make an alcohol from alkane, let's just say the exam does that to you, Ainesh, what is the route that you must take according to this map?
This one.
Go to the second family first, and then from the second family, go to the third family. That's the route to take. Simple to understand, right? Okay. Now I'm going to draw. So the arrow is, This arrow means going from alkane to alkene, and then the other way around. I'm going to explain this reaction first. Now, you know that this is C2H6, and this is C2H4. Ainesh and John T, do you have to memorize that it is C2H6 and C2H4, or can you understand them?
No, don't need.
Hopefully, you can understand it. Now, Ainesh, how about you?
Yeah.
Can you understand them, not just memorize them?
Well, I need to go take water. I'll be back in like 1 minute.
Hey, what are we doing?
I think John T want to go to the bathroom. I think that's one.
Okay.
Yeah, just 2 minutes. Just 2 minutes. John T, you're back?
Yeah, I'm back.
Good. Look at the bottom reaction. This should come as no surprise at all. Can you see the logic of the bottom reaction? Can you see the logic?
Like this too.
Which one, John T? Tell me.
Like
No. I'm just talking about this one. I'm just talking about this one.
Oh, bottom.
Just one reaction here. Just one reaction.
Yeah.
I'm going from the alkene family to the alkane family, and I say the reaction is as simple as adding hydrogen gas. Does it look like it makes sense?
Yes.
Why does it make sense to you, John T?
Hydrogen is above. No, wait, no, it doesn't.
It doesn't make sense, right? We'll try to make sense of it. How about you, Ainesh? Does it make sense that I say something like this? Hey, guys, alkene, if he wants to become alkane, I just put in hydrogen. Make sense or not to you, Ainesh?
I was going to say, yeah.
Why does it make sense to you?
Because that's how this thing.
Again, tell me in more detail. How come it makes sense?
This one requires 4H to work. This one requires 6H to work.
So I guess adding H2 makes a lot of sense, right?
Yeah.
Makes it easy to understand also, right? That's the first reason. Very good. I'm going to give you the second more detailed reason. Then it should make total sense, right? To you, Ainesh and John T. So look at what I'm doing. I'm already describing this reaction, yeah? So I have my drawing. I explain using drawing. This is so important. The drawing is so important for our understanding. So H2 looks like this. Any objections? Right. Okay. So the double bond. Remember that the alkene family have single bond, right? So one of the double bond will break. No explanation given, but it will break, and therefore there will be two hands dangling from each seat because one of the double bond breaks. No explanation why it breaks, but it is very easy to break. Does this process make sense so far, Ainesh and John?
Yes.
So, well, guess what? The hydrogen bond also break. Kind of easy to break. Once these two breaks are achieved, well, voila is a very simple thing to see that, well, you have now the new thing. Look. There you go. Look. Visually, does this make some sense, Jonty?
Yes.
How about you, Ainesh?
Yeah.
If this makes sense, then I'll give you the proper name. The proper name is hydrogenation. A very not creative name, right? Hydrogenation. I mean, what's so difficult to remember? It's adding hydrogen. So addition of hydrogen. Hydrogenation is addition of hydrogen. They are used interchangeably. Okay. Is the reaction okay? And is the naming okay? Ainesh and John. Okay.
Uh-huh.
All right. Yeah. So now, Ainesh and Jonty, the reverse reaction. Now I'm talking about this one, the reverse reaction. The reverse reaction is unfortunately a little bit more complicated because we cannot just minus H2. I wish we could do that, but we can't. The reverse process is called cracking. There is a reason why it's called cracking. Cracking will be one of the first reactions your teacher explained to you, not the last one, the first one. And therefore, I will reserve the explanation to your teacher. For some reason, everybody understands cracking when teacher explains. So I just leave it to the teacher. What I want to say is it's not as simple as minus H2.
I think I got learned before.
You're saying, John D?
I think I got learned before.
Good. If you have learned before and you don't understand, well, I can explain to you more. Usually people find it kind of easy to understand, even though it is complicated. Right? So your teacher will repeat it a lot. If after 2 sessions you still don't understand cracking or you cannot apply, yeah, totally gonna explain to me. Okay? So we'll keep it at that first. Ainesh, are you okay?
Yeah.
So I've explained to you fully about hydrogenation, which is going from this way. And then I did not explain to you at all about cracking. I just mentioned the name so that when teacher explains, you will get it. And with that, this part of the reaction map is complete lah. You know, going back and forth, it's complete. Okay? Okay. Now, I'm going to take a detour and add a few more reactions, right? I'm going to talk about the reaction like that, and I'm going to talk about the reaction like that. Now, notice that these 3 reactions all goes out from the alkene. So this one goes to alkane, this one goes to alcohol, and this one goes to unidentified object. I'm going to make a circle, right? Okay, so now plus H2O, also called hydration, which is not a creative name at all. I mean, water is hydro, so hydration, or the other name is addition of what? Jonty, make a guess. Addition of
Water.
Water, which is again not creative at all. By the name only, you should already guess that the process is going to be extremely similar to hydrogenation, which is why I discussed hydration first. Now, your job, Ines and Jonty, is to make sense, understand hydration. No point memorizing at this point. A lot of point in understanding. Can you understand why going from alkene to alcohol is a simple hydration, addition of H2O? Give you 1 minute to think about it. You can draw things if you want to, preferably on your paper, but I guess you can draw here if you want to. So Ines, if you're going the route of drawing, which is always a good idea, you want to draw like the complete structure. That's how you can understand, I suppose. Also better using paper, Ines. I feel that it's better to use paper.
Yeah, I don't need to draw. I think I understand.
You sure?
Yeah.
Well, then explain to me how come adding H2O makes it alcohol.
And that's because, I mean, I don't know if I'm oversimplifying because that's the difference between these two formulas.
Of course, that is the first reason, with the reason that you explain for this one. Totally happy with that. I want a full explanation coming out from you. Your first explanation is totally great, totally correct. But a full explanation is what we're aiming for today.
Okay, so they remove the double bond.
Yep. Break
So
the
that
double bond. No, don't say remove. Break. Break one of the double bond.
okay, they break the double bond. So now there will be two spots open, kind of.
I know. Yeah, something like that.
So then one becomes H and the other one becomes OH.
Which does it make C2H5OH?
Yes.
Yes, and you are correct. Okay, good. Jonty, do you get the explanation?
I think I understand. He just said like he break one of the double bonds. Then,
Correct, which is the same thing as the hydrogenation, right? But
yeah,
now
then you add
here we have
OH and
HOH, correct? Instead of HH, we have HOH lah, which is H, right? So we break it here, and then suddenly this is H still, and this is now OH, which voila, isn't that an alcohol? Correct? Isn't that an alcohol?
hydration.
Yeah, hydration is adding of hydro, whatever lah, addition of water lah. That's the point. Okay. Now, you can complete your drawing later. I'm gonna do the last arrow here. So we completed this arrow, and this arrow. This arrow will be plus, in this case, Br2. Now, your job, Ainesh and Jonty, is to draw the result of adding bromine, bromination. Totally not creative name.
Can you repeat?
You're saying, Jonty? Sorry.
Can you repeat what you said? Like addition of bromine.
See, I here draw bromine, correct? Br2, right? Which is called bromination, addition of bromine, like not creative name, right? Correct here? Okay. My question to both of you is, please draw the result. Guess what the result is. Okay. I do need you to draw, okay? I do need you to experiment somewhere.
I think I know already.
Right. I need to see some drawing, Ainesh. All right, I'm seeing some. Ainesh, I'm okay with you drawing this, but why are you drawing this? I'm asking you to focus here. Totally fine with that. But please focus on this one. I need you to guess the result here, right? The exact drawing of the result. Jonty, you okay?
Yeah, I think it's this.
Right, so I need you to make a guess lah. Okay, I think Ainesh has guessed properly. This is the result, like as simple as that lah. Right? As simple as that. Right? Now, I think we can see the point of hydrogenation. We can see the point of hydration, but bromination doesn't seem to lead anywhere. At least not the four families lah. The four main families is not you worry about. Okay, so why do we learn bromination? Because that's one of the most asked reaction for unclear reasons, because it doesn't lead to one of the families, right? It's a bit weird that bromination is one of the often asked reaction lah. Anybody can guess why? Just make a guess. Ainesh?
Cause it's
What
diatomic.
does it make?
Sorry, Ainesh first. You're saying Ainesh?
Cause it's diatomic.
It's diatomic, but hydrogenation is also diatomic, right? H2, right?
Oh yeah.
Right. So perhaps not the reason. Jonty, you were saying?
What does it make?
I'm sorry, you're saying what?
And what is the compound that we drew? What is this CH thing? If it's useful, then they'll want to teach you.
Yeah, this compound is the result of bromination, breaking one of the double bond, breaking the Br2 and inserting the Br there. Simple, right? Totally the same process as hydrogenation and hydration. Make sense? It doesn't make sense, again, tell me. Now, my question is not why this is true. I think you can kind of see why it is true. My question is, why is this reaction important to study? I'm asking you to make a guess. It's not easy to guess. But can you guess what? So here comes the explanation. I mean, it's not easy to guess, but at this point, you should know the color of bromine already. Ainesh, what is the color of bromine?
Color of bromine.
Yeah, you kind of have to make a guess because you seldom see the color of bromine. But if you could guess.
Gray.
Gray, no. There isn't much gray stuff here. So
Brown.
yeah, brown, which we kind of have to memorize because again, bromine is not a common thing, but yet there we are. Bromine is brown, usually brown liquid. Oh, liquid is another thing to memorize. There's only two liquid at room temperature in periodic table. One is bromine, there you go. The other one is mercury, which we are not interested in. Right, so bromine liquid. Now, tell me, Jonty, what happens when alkene, which is colorless, mix with the brown bromine? What do you think will happen visually?
You turn brown.
No, it will turn colorless. The brown color will disappear.
Oh.
Does it make sense?
Yeah, makes sense.
How does it make sense, Jonty? How come the brown color disappear?
Because the bromine gas is brown at first, right? Then when you break it out, then it's not brown.
Better say bromine liquid because it's liquid and gas. So
Right.
liquid part the liquid part. Why does the liquid brown color disappear again?
Because you separate the bromine.
And then it combines into this thing, which means the bromine is gone, which means the brown is gone. It will be just colorless. Yeah, how do we know that this is colorless? Well, just memorize most things that we study are colorless or white anyway. So the brown color disappear. Now, Ainesh, are you okay with this?
I'm not very clear.
One more time, colorless thing, right? How do I know? I mean, I'll just tell you first. Alkene is colorless. Plus a brown liquid. So far, so good?
Okay.
And then you draw this wonderful thing, which is the result. But you do notice that the bromine kind of is gone, right? Do you notice that? The bromine is gone when the reaction is finished. The bromine is now inserted here. It is no longer Br2. No longer. The Br2 is no longer there. Can you accept that?
Yeah.
Therefore, the brown color disappears. Therefore.
Okay.
Which is a big deal, at least in O-level, because it is used to identify. This is an identification reaction. That is why we learn. So I'm going to give you the full story. Very simple one. Bromination cannot happen with other people, other family. Bromination only happens with alkene. Therefore, the brown color will disappear only if there is alkene. Only if there is alkene. If you put brown liquid into an unknown substance and the brown color disappears, you know there's alkene inside. That is identification. Is that okay, Jonty?
Yeah.
Is that okay, Ainesh? Not okay, just tell me.
Okay.
Now, here's the last question before I ask you to repeat. How come we cannot identify alkene with hydrogenation and hydration? Both reaction. Why invent another reaction for identification purpose? Why?
Wait, identification of bromine or
Not
alkene?
bromine. No. Bromine is easy to identify. It's brown, ma? Correct? There isn't much things which is brown. We're talking about the identification of alkene by the disappearance of the brown color. Does that make sense?
Yeah.
Tell me if it doesn't. It doesn't.
Yeah,
Tell me.
makes sense.
All right. So I'm going to identify alkene using a brown liquid, which will disappear if there's alkene, right? Because of the reaction. How come I don't just identify using hydrogenation and hydration? I mean, why bother studying another
It
reaction?
doesn't change the color.
So we cannot identify visually nicely. No? We cannot identify using hydration. We cannot identify using hydrogenation. So we cannot. That is the I believe the very practical reason why we have to study another reaction. Will that be okay, Ainesh?
Okay.
Right. Now, before we continue, you guys are already quite advanced, right? We covered this reaction, we covered this reaction, we covered this reaction, we covered that reaction and the result. All right. Now, I'll give you another good news. Here, the reaction is there in A level. In O level, you don't have to study. Okay. I'll just tell you the name just for, FYI. The name is dehydration. Doesn't that make sense, John T?
Yeah.
Because this one hydration, so this one dehydration, no, yeah lah, but we don't have to know that in O level. We don't have. Okay, so I've covered quite a lot here lah. 1, 2, 3, 4, 5. And then notice that here there is no arrow back lah. I just want to say that to you. Here there is no arrow back. Nor are we interested because our interest is only in identification for this reaction. Okay. I will add one more reaction and then I'm going to ask you to repeat, right? That will be halfway already. Now look at my next reaction. Totally easy to understand. Arrow in, arrow in, arrow in, arrow in. I draw 4 arrows in. This represents just one reaction. Everything plus O2. Now, Ainesh, what do they call the reaction plus O2?
Oxidation.
I'm sorry, what is it, John D?
Oxidation.
Oxidation, yes, but I'm looking for something more violent than oxidation. What happens when you take a can of petrol and then you never mind. It's combustion, just tell you, combustion. I am saying to you that all the 4 families are very easy to burn. It should come to no surprise to you that alcohol is easy to burn. Alcohol, easy to burn. Just add oxygen, which is everywhere, add a little bit of spark, and then you will make it into CO2 and H2O. Extremely easy to understand. This reaction is something you actually know already. All 4 of this can be burned. Basically, combustion. Once it is burned, you cannot return them back. Also, something that you know from real life. Any question on this reaction? Okay. Right. Yeah, combustion. Plus O2, please. Plus O2 becomes CO2 and H2. At least know that. Right. So Ainesh, I want you to take a paper, and John D, I want you to take a new paper. I'll give you 1 minute to look at the reaction that you have been writing here, and then you're gonna close it, and then you're gonna repeat gonna redraw the reaction map from scratch.
But you never say like that. Do you cover in between combustion?
The bottom one haven't. The bottom one is harder. I cover half of the easy one. The bottom one will be harder. This is only half.
Okay.
You are correct lah. I haven't covered everything. Correct. Anesh, I need to see a paper. I think this one has to do in paper lah. Better lah. So John D, another piece of paper cover.
You just need scratch paper, right?
Yes, scratch paper is fine. Totally fine.
Give me a little more time, then I'll write notes. Like I'll write the notes of this instead.
You can, Ainesh, but I'm talking about a scrap paper right now. I want you to rewrite this from memory without looking. It is not going to be your note. Your note will be something nicer that you make later. Understand? This will be on scrap paper. Don't worry about the result. Just do as much as possible from your memory or understanding lah. Okay? Don't look at the Jamboard yet. Don't look at it yet. Trust your memory and understanding a little bit lah. I want you to do that. If you forget something, John D, or you're not sure, drawing the structure might help lah, right? Okay. Come on, Ainesh, quickly. Right, scrap will be nice, right? No. Okay, seems like a good start, Ainesh. You're starting with drawing. Okay, very rare of you to start things visually. I like your start. John D, I'm seeing some drawing. Nice, very nice.
Isn't this I lazy to write out the.
Yeah, totally fine. And your arrow is correct. The important is the arrow lah. So you know where's the plus, where's the minus. Okay, try to draw the other family, John D, to complete the big C lah, because then it's easier for you to draw the last reaction, right? Okay, Ainesh, that's a good start. That's not a bad start. Good. Nice start, Ainesh. Nice start. Good. Right. So John D, add the brown color in BR2 just to remind you that it is for identification purpose. Okay, John D, you did well, not very difficult at all, right?
Yeah.
Okay, I'm gonna do all the difficult stuff after this lah. So this is a very good start. Okay, we're gonna give Ainesh time. Okay, this one is important to simply absorb and take it slow. Right? If you're fast, then good for you. But we will try. Okay, if you have other questions first, John T, I can answer them lah. If not, we'll wait. Okay, we'll wait.
Alright.
Okay, going strong, Ainesh. Going strong. I'm not rushing you. Yeah, you take your time. You're writing nice stuff, very nice stuff. Yeah, very nice. Draw the fourth family, Ainesh. Even though you don't know the reaction, draw the fourth family. There's always four family to consider, man. Draw the fourth one.
But yeah, what about the last one? The last one, like not into the reactions.
I'm gonna give you. Hopefully, I can give you most of the remaining reactions, but they are usually difficult lah. So it'll take some time.
I mean, as in like the last family.
You mean the carboxylic acid or what?
No, because there's 5. Last time you said there's 5.
Ester. I'm gonna show you Ester hopefully today. If not, then
it's called Ester.
It is called Ester, like Ester without the H, and Ester will be important, right? So Ainesh, you're going strong with all the reaction. You do forget cracking, the name of cracking. The name cracking, so it's a bit of something that we don't understand. Just okay, the name, good, and then you forget the easy reaction, which involves all 4. Remember the last thing I told you just now, the one that goes into the center. Everything visually it goes to the center. Look at the Jamboard. Look at the Jamboard. Do you see it, Ainesh? Put the last reaction that you're missing. Put the last reaction. So I know that you get it.
Yeah.
Right. Do write down, please.
Needs to be add oxygen, then carbon dioxide, and what?
Adding oxygen means combustion, burning lah, burning lah. So you burn everything in the presence of oxygen, and everything will become CO2 and H2O. Everything can be burned lah, basically. Yeah, so arrow in plus O2 becomes CO2 and H2O. Good. Okay, any question, Ainesh?
No.
Right. So now look at page 7. Okay, what I have covered looks like this lah. So, oh, sorry. The 4 families are there. I've covered this arrow, and then I've covered that arrow, correct? I've covered this arrow, and then the other arrow is not in the syllabus, so I just dot. There's a 1 arrow going there, right? And then there are 4 arrows going in. At this point, even though I don't write anything, you should have a very good idea what I'm talking about. Correct? Jonty, you look at this picture, it doesn't confuse you, right? You know what's going on. Ainesh, you look at this picture, you know what's going on. Correct or not?
Yeah.
Now I'm going to talk about the remaining reaction, which needs more explanation, right? So 1 arrow out, 1 arrow in, 1 arrow out. Difficult to memorize, better try to understand, and 1 reaction there, right? And then finally, the last one will be these 2 combined into the last one called ester. That's your ester later, right? So let me start with, you're gonna choose randomly, Ainesh.
Hey, can you write the formula in the circle? It'll be a lot easier for me.
I will draw it. Okay, even better.
Yeah, I'll let them.
No problem. You're right to say that better rely on the picture or the formula at least. So you're correct. Your instinct is correct. I'm going to do that. Now, Ainesh, you're going to choose 1 reaction of the red one, the remaining one. Just choose 1 randomly, and I'm going to start explaining from there.
Okay.
Which one? All right, that one. This one is plus Cl2 with UV. Plus Cl2 with UV. Before I explain to you how it works, I'm going to explain why we learn this lah. Because I think knowing the why is important. This is your this is why you avoid UV in the sun. Not the chlorine gas specifically, it's not. The UV is the problem here. Let me tell you that alkane is a very stable compound, and your skin is made up mostly of alkanes, mostly. Okay, just take it that way first. Nothing will happen to your skin if not for the UV. The emphasis here is not the Cl2. That one I can guarantee you. The emphasis is the UV. UV enables this reaction. That's the learning point. The UV is the cause of the problem. Because when alkane change, well, your skin change. It can lead to skin cancer. Too much UV leads to skin cancer, and that is true. Okay? It's not just sunburn. Sunburn is not the problem here. The fact that your skin changes is the problem. right? So this is why we learn this reaction, so that we know to avoid UV, at least to use sunblock, right? Okay, you might not care if you become darker, right? But you should care that you don't get skin cancer. In this case, Ainesh, your darker skin than us is a benefit actually. Do you know why?
Why?
Because your darkened skin is pigment, and pigment is very good at absorbing the UV harmlessly. So in this case, your darker skin is a benefit. It's like a natural sunblock. You still get burned though. So, you're saying?
The red arrow, it becomes what?
Right? Become what? Try. Right. So what happened is this. So the UV attacks. This is a bad thing, by the way. This is the bad thing. So the UV attacks one. Attacks one, and then it allows the Cl2, which is done like this, also attacked by the UV. Wait, what does your teacher? Oh, I'm sorry. Your teacher will teach the simplified version. I'm sorry. Your teacher, if he goes in detail, will tell you that the UV attacks the Cl itself, easier to understand. And then the Cl will replace the H. So he does a swap. So this is now H, and this is now Cl. Just like that, the alkane is no longer alkane. In our case, that's a bad thing. Okay, this is a swap. This swap is only enabled because of UV. Because this is a swap, the name of the reaction, it represents that substitution.
And then hydrochloric acid is born.
Kind of, but HCl and the Cl2 is not the point here. It is a result, true. But the most important thing is this, the alkane change. Let me put it another way. Let me put it very clearly here. This is cracking, right? Remember, I never explained cracking. I'm going to explain a little bit. Cracking is a very high pressure, high temperature process. Why am I telling you this? It's because it is very difficult to change alkane. Very difficult. You need high temperature and high pressure in order to change alkane to alkene. And now the other reaction here is you need UV. Also not possible without UV. To change alkane, it is difficult. Use UV or use high temperature, high pressure. If not, the alkane don't change, which is good for us because we are usually made out of long change of alkane. Let's put it that way. Good for us. Okay, so this reaction is important because it tells us how to change alkane, something like that. That's as well. Any questions so far?
No.
As I promised you, the reactions after the previous one are needs more explanation, right? So Ainesh, you sure? No question?
It's just still understand. Is hydrochloric acid produced or not?
It is because the Cl swap place with the H. So you have this and then you have HCl. Yes, the HCl is produced. Correct. It is.
Then what happens to this? What is this called? What does it do?
What does this do? This is not an end product, which is, I'm sorry. Let me give you the slightly full answer. This product is actually a very useful product if you are trying to make other things. This is another family. You don't learn that this is another family in O-level, or rather in year 4. If you go to year 5, year 6, and you take higher chem, so to speak, then you will learn about this family. Both of you are very unlikely to go for year 5, year 6 chemistry. Am I correct, Ainesh and Jonty?
Yeah.
Ainesh?
I don't know. I'm not sure. I think I have to.
If you have to, then you will meet this family and they will say that this family is very nice and useful. And then they will explain why. But in year 4, we scale back on the explanation and we stop here. We just say that this happened without an explanation of, so what's the point? I mean, that's why I'm trying to give you the point. The point here is avoid UV. For now, for now. But in year 5, year 6, you will learn how to harness this for good, to make other things, But for now, we stick to avoiding UV. Will that be sufficient, Ainesh?
Yeah.
Again, the point is not to make HCl, okay? There are many easier ways to make HCl. HCl is just a byproduct, right, in this case. Any other questions? Those are good questions. Okay, so that one's done. Now, John D, you get to pick the next one.
Ester one.
That's the one. Okay. Now, according to the arrow, it is absolutely clear at this point that I'm going to combine alcohol and carboxylic acid into a new substance. That is what I'm going to do. This reaction is very important and also complicated to explain. Let me try my best. Ding, durung, during, durung, during, durung, during, durung. Notice that I am preparing my carboxylic acid and my alcohol by, I'm so sorry. Reorienting, sorry. I am reorienting the carboxylic acid. Ainesh, am I allowed to do this or not?
Sure.
Yes. Any objections, Jonty?
No.
Right.
Yeah.
Now, I am reorienting this, and you should do that also, especially because you're a beginner, because the reaction will happen here. I am going to just circle. This part is a bit of memorization. You do have to memorize that the reaction will be like that. This is a very specific cut. I am cutting it here and here. And yes, you do have to memorize the cut because this is OH and this is OH. Very confusing, man. Even though this is COOH, I'm just dealing with the OHN and the OHN. And I'm specifically cutting it here and here. What is the end result? I'm going to draw the end result for you. And my mistake, I should have used a different color because this is going to be important. I'm sorry, I should have used a different color. Sorry, yeah, let me do that. C sub sub C sub 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 sub. There you go. Okay, so I'm using a different color. Now, the end result looks like this. The end result, first of all, will be H2O. Now, where did the H2O come from, Ainesh? How did this H2O comes from? Where?
This one.
Where? No, from here. From here.
Oh.
Partly from the green one, partly from the blue one. So partly from the carboxylic, partly from the alcohol. Yeah, I have ejected H2O. Why does this happen? For now, we have to memorize that it does happen, and it does happen quite easily somehow. It does. Ainesh and Jonty, clear why I suddenly have H2O?
Yeah.
Now, what remains is what is important. What remains is the ester. So I'm going to draw the ester, right? There's the C, right, from the alcohol, blue one, right? With the O, right? With the O, and then I'm going to do the green one. So they basically combine, right? Ding dong C, ding ding O, ding C, tut 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 tut. Now this is your ester, a combination of the carboxylic and the alcohol. At least, is it somewhat clear what's going on?
What happens to the spare H?
Oh, sorry, what happened to that?
What happens to the spare H?
There is no spare H. What do you mean?
H2O, right? H2O. But there's The O doesn't partake in the reaction. It's only the
Yeah,
H.
yeah. So the O, there's one O here, right? Which is the yellow. Yeah, there you go. Right, and then this O now connects to this C, which is what's happening here. Be very clear about what's happening structurally. Be very clear about this. Before I tell you why we learn this. This one, be very clear because it's very important reaction. This reaction leads to other things. Ainesh, are you okay? This is kind of complicated. Better understand.
I don't really understand.
Then better draw. Right. Ainesh, do you kind of get it?
I think so.
Right. Then for closing, we are already 3 minutes away. So I'll give you 2 minutes. Draw this. Draw this on your paper and figure it out. You got to figure out by drawing. This one I guarantee you. Draw it, please. In your scrap paper, by the way. In your scrap paper. I'll go get some water first. Ainesh, please help zoom in a bit, please. Right? So I can see much better, right? The connection today is good, someone. Nice. Okay. Jonty, why are you not writing on the scrap paper?
I'm a bit confused.
I mean, try to don't look at it and draw. Now for you, Ainesh, I am all right. So I'm very happy with your result. The only thing wrong is your cut, the H2O cut. Just look at my drawing, just fix that. It is a memorization thingy. It is important to memorize. You do a wrong cut. First of all, you cut HO2, which you're cutting 2O and 1H, which will not give you H2O, right? Does that make sense? Secondly, the cut is also done wrongly. So please observe how I do it and do a proper cut. The cut is important. Right? Draw back the OH, right? The carboxylic acid, instead of drawing OH, draw HO. I hope that makes sense. And then draw a proper cut. Yeah, that's a nice cut. And then all the OH, nice. Why is this correct? Memorize for now. But you're doing very well. So Ainesh, I hope this is enough to compensate the fact that we're not studying math. Okay. Ainesh, you may want to rest. I see you tomorrow. Do you want
tomorrow 1.5 hours? I have to.
Right. Tomorrow you can go longer if you want to for your needs. It's okay. That's up to you, right?
How long are you in the Zoom call tomorrow?
So I'm always in the Zoom from 7:30 to 10, always, right? Okay. So if you need to tomorrow, you can go longer. If not, I suggest Wednesday is less crowded, right? Depends on when you want it. Okay.
Okay. Sure.
Right. All right.
I don't understand this part.
Which one?
I don't understand the H2O, then the arrow.
Right. So you did a proper cut, right? You cut one H from the alcohol, you cut the OH from the carboxylic acid. Don't know why, but that is what happened. And both the H and OH will simply form H2O. That is the explanation they give you in O level. That's about it. Look, is that enough?
So it's just like that, lor.
Yeah. So you kind of eject the H and OH, they will form H2O. And then because you eject them, the remaining alcohol and the remaining carboxylic can hold hand. They become ester.
Oh,
For an important reason, talk about after this. We haven't talked about the reason why we study this. All right.
okay.
For now, I do mean it when I say you have to remember this clearly. You have to. So, right. Any other question?
No, not really.
Right, good job for today. I doubt that next week your teacher will reach at this point. So I think next week we can finish the math and then talk about the last part, and then we can start looking at the exam question, which should make you more confident. Okay, Jonty, I'll see you